The dream machine. DICOM, HL7, IHE and Snap. We're building the future, never looking back.
Quick note off the top before we get into this episode. This conversation was actually recorded many months ago. We ran into some issues recording the video and a few delays getting it out. But after re-listening to this, I'll be honest, it was too good to sit any longer. So this is an audio only episode, but the content absolutely holds up. Today, I'm joined by Dr. Khaled Younis. Khaled is someone who brings a rare combination of experience across AI research, clinical imaging, and global standards. He's been working in machine learning going all the way back to the early days of computer-aided detection, and today he's deeply involved in shaping how AI actually gets used in healthcare. He's active in IHE, helping define how AI fits into real radiology workflows, and he represents the US at ISO in AI standards committees focused on risk management, bias, and trustworthy AI. He also chairs the SIM Machine Learning Research and Tools Committee. And that background is exactly why this conversation goes deeper than most. We get into where AI in radiology actually stands today. Not the hype, but the reality. Why, despite hundreds of approved algorithms, AI adoption is still quite uneven. We break down the real barriers. We look at clinical validation, regulatory scrutiny, interoperability challenges across PACS, RIS, VNA, the EMR. And we look at the trust gap driven by bias and lack of explainability. We also connect that back to history. We look at early CAD systems and why they lost trust and what lessons that we can still apply from this today. From there, we get into some of the more forward-looking areas, including federated learning and how it allows models to improve without moving data. We look at synthetic data and where it helps and where it can actually make bias worse, and the role of standards like IHE and ISO in making AI outputs usable and scalable across systems. And we close out on where this is all going next: real-time decision support, AI-guided interventions, and the shift toward truly multimodal healthcare data. And if you're listening to this and realizing you want to better understand how all this fits together, the workflows, the standards, the real-world application, that's exactly why we built our training programs. You can head over to nagelsconsulting.com to check out our courses, including the CIIP Foundations program, which is designed to help you build a structured, practical understanding of imaging informatics and prepare you to take the CIIP exam. So with all that said, let's jump into this discussion. So welcome, Khaled. I'm very happy to have you on Imaging Informatics Unplugged. And today we're going to have a conversation, and it's going to center around AI and machine learning. And maybe just to start things out, AI and machine learning, these have been big buzzwords ever since 2012 and AlexNet, and we saw the opportunity of impact that was going to happen. So that's quite a bit of time that's happened since 2012. We're in 2025 now. I wanted to get your perspective on where do you look at where we stand today in terms of AI adoption in radiology specifically, and then even beyond radiology and other imaging domains as far as adoption. And what do you see as kind of right now that being some of the biggest barriers to wider implementation?
Well, first of all, thank you very much for having me. I am really excited about the discussion that we will have regarding AI and informatics and imaging. As you mentioned, machine learning and AI have been there for even before 2012. Actually, I did my master's and PhD on machine learning, and that was in the 1990s. And we worked on breast cancer, computer-aided diagnosis, which is applying AI to detect masses and microcalcification. Now, I believe that AI in radiology has made significant progress, but full adoption is still an issue, and because of different factors. I see now a lot of AI used. There are tools for detection, for segmentation, for workflow automation. You find it for triage and decision support. The regulatory approved AI products are, now more than 1,000. The majority in radiology, about 70 plus percent. And that's a good indication of the adoption. But as I said, still we have to look into other regulatory as well as other barriers to what is really needed. So currently there is a need for strict clinical validation, and that makes it very expensive to go through the clinical validation for products in AI that requires regulatory approval. The other issue is interoperability. And you know that there are many systems in the radiology department and the healthcare industry that need to talk to each other. You have the PACS, you have the RES, the EHR, and until now, there are some problems in getting the information, the images at the right time. Now we go to the cloud, and that also introduces new challenges. So even though we try at the IHE to work on profiles that make it easy for vendors to apply the standards, DICOM, FHIR, HL7, in a way that improves the workflow, but interoperability is still a major hurdle. The third aspect that I think is a barrier is the bias, like the harmful bias that is introduced in these systems. And even though there are some standards and guidelines to reduce the risk of the bias, and you have some states that even introduced their own rules, acts like California, for example, and New York to counter the issue of bias and generalization, because the models are always good on the data that they are trained on. If you don't have a diverse data set and you don't induce some guardrails and some balances, checks and balances to make sure that the AI model is trustworthy and responsible, then that will still cause a lot of issues with the ethical application of AI. Then all of that will, of course, contribute to the clinical trust and adoption. If there's a trust, there is adoption. Like radiologists like to have an explainable AI. Like they still want to be in the loop, like human in the loop oversight. So they don't want to have a system that will replace their ability to make decision or to bypass them. They like the AI system to be their assistant.
I think they still hear the haunting words of Jeff Hinton saying they were the coyote running off the cliff.
Exactly. Yes.
I'm curious. You've touched on a few points. I want to touch on the regulatory, the interoperability, and the bias, because those are really great kind of barriers that we're seeing. Before we go on there, I wanted to start back at what you said, because you make a great point. 2012 was not the beginning. It's when the hype began, maybe currently. We've always seen these valleys and peaks of AI, and there's the winter that sets in sometimes. So you mentioned CAD markers, and so these were opportunities to detect calcification in the breast, looking for the opportunity of identifying potential breast cancer. And where that was, I guess, as the process of looking at those models, and they would have been very primitive compared to what we're looking at now. And maybe my naive perspective is those didn't see the same type of success that we're seeing now due to just limited processing power. And that may have been part of it. But do you see comparisons between the barriers that were existing back then and eventually the AI winter set in and people kind of walked away from trusting CAD markers and that to any comparables, any parallels that we're seeing from then to now?
Yeah. Well, actually, the solution that I told you about is part of a company that we started in 1996 with actually my advisor in the master's thesis, Steve Rogers. The process was already examined by another company, R2, which is now Logic. Um, and Marilyn Geiger from the University of Chicago actually was one of the pioneers in convincing the Radiological Society that CAD markers can act as a second eye, and it helps the radiologist not to miss some real cases of cancer. What went wrong with, I think, the early CAD is that it used to highlight masses and it tried to actually diagnose or find if there's a real mass, malignant versus benign, and the technology was not ready for that. We used to have the traditional machine learning, which depends on getting the features extracted after a lot of stages of image processing, because we used to have film at that time and we needed a digitizer. And the different digitizers actually have different properties. So if overall, when you look at the grayscale on the digitized mammogram, you will find that it's different depending on the actual digitizer. So the same optical density, and that can have effects, of course, on the algorithms, the features that you were using to detect. So instead of that, then came the idea that, okay, we'll just do queuing, basically, which is just highlighting, as you said, some markers that, please take a look here. Many of the algorithms were actually heuristics. Heuristics, like in the sense rule-based, and if the size is this much, then apply that, and you have to experiment with a lot of features. And that did not work. It's not as easy as with deep learning, where you basically provide the images, sample images with the classes, and then have the algorithm, the model, extract the feature itself. It decides like which feature to look at and which feature to ignore. And that basically rendered all of the research in the feature extraction, useless or not very relevant. Still, you have to think about the complementary aspects between deep learning and the features extraction. So in addition to the image, you can also provide the features as input to the data, and that will have shown to be really useful, because you have to have the insights from the radiologist. So VA was approved actually, but it was controversial. Radiologists actually, they just ignored the CAD recommendation because they didn't trust them. But if you look at the causes, as I said, you have very limited processing power, limited GPU. There are a lot of false positives, which made it actually more stressful. It introduces more work to the radiologist. So there was a lack of trust, lack of explainability, and the FDA approval actually came before the actual testing on the ground. So that led to the disillusionment, as you described.
The trough of disillusionment, yes.
Yeah.
And okay, so then bringing us back to today, you mentioned regulatory, and you've mentioned the FDA a bit here. And so nowadays, we're seeing an abundance of vendors that have been getting FDA approval over the past little while. I suppose it'll be interesting to see what happens, because I think there's been some changes with administration in the FDA, and we'll see how that affects either an increase or a decrease in the number of approved models. Curious, do you have any thoughts about which direction we might see that go? More opportunities for vendors to have approval, or do you think there'll be greater resistance now that there's been some changes with regulatory bodies?
Well, as I said earlier, you can't really predict how things are going because we are still in the process of the changes. That's why a lot of AI vendors are actually watching closely to see what's going on. For sure, FDA has accelerated AI adoption in recent years, and especially in radiology. And we saw that. But now, if we look at I think you will see a tighter scrutiny. I think uh, there is, of course, we noticed the surge in the FDA approvals. The software as a medical device in 2018, if you look at 2024, there were, as I said, more than 700 AI ML based, and one of them, of course, is the X-ray tool that I worked on with GE Healthcare for pneumothorax detection algorithm. But we see the trend now to real-time monitoring. In 2021, they introduced the continuous learning AI, the ability to not go back to the FDA all the time if you have an established. And I remember in 2019, FDA also were discussing some ideas about that. And there was a lecture by the FDA, but still there is not much going on right there. So there's still need for post-market surveillance, and vendors need to show that their system is acting reliably in the market. So, as I said, I believe that there will be more scrutiny now, and the scrutiny maybe not only on the performance, but also on the bias and the explainability. So, the clinical validation maybe needs longer and multi-center trials before approval. So that's one way, to look at. But are, of course, some changes. FDA is also working on the PCCP, the Predetermined Change Control Plan. That is AI model, that I described earlier. They have been working on that for a very long time.
And so one of the other areas that you had mentioned was interoperability and challenges. You're heavily involved in IHE, and I believe you are also involved in ISO. Is that correct?
Yes.
So maybe there's been a lot of efforts. There's been some new IHE profiles over the past couple of years that have tried to zone in and focus on the AI results. There was a great white paper from IHE that looked at the different areas that vendors can look at as far as applying AI in the workflow, and within mind of interoperability. And a lot of times we think of just the computer vision aspect, but there's workflow, there's procedure guidance, there's so many areas that it can cover. What are you seeing as far as the development of interoperability as far as it goes with standards? And I'd love to hear anything that you have to share about the ISO perspective from what you're seeing.
Okay. Yeah, this is something that is near and dear to my heart. I am indeed involved in the IHE Radiology and the ISO IEC, the International Organization of Standard, and the International Electromechanical Technical Committee, and specifically in the Joint Technical Committee one, which focuses on information technology, and in the subcommittee of 42, which is the committee that is in charge of artificial intelligence. And regarding what you mentioned about the interoperability advances and the IHE role, we worked on many profiles, like, for example, the AI results introduced in 2020, and then later on we had modified that and released a new version in 2022. And we also looked at the diagnostic imaging, radiology, the FHIR, the interactive multimedia reporting. And the goal of that is to encourage the providers to utilize a structured way of representing the AI result. And we suggested the TID 1500 as the right vehicle to represent most of the AI outputs, so that it becomes machine readable and it allows the study of the performance of different providers without the need to reinterpret everyone's output in its own format. Some people provide the output like in a structured report. Some people do it with encapsulated PDF, or some of them do it in a structured report, not following the standards. The reporting is where we focused more in the previous years in IHE, and because we felt that this is where the industry is moving and adopting AI in the clinical workflow. ISO, on the other hand, I represent the US in the subcommittee 42 on the expert level, and the goal there is to work on the AI risk management, fairness, transparency, and bias mitigation. So there we developed a framework for trustworthy AI. So it's done for the government level, because there are 47 countries, national bodies who are part of ISO IEC, and therefore the goal is to ensure that these aspects, compliance, auditability, are taken care of. And actually there is another group that I'm working on, I'm part of, which is the Technical Committee 215, which is health informatics. The focus there is on the AI in the electronic health records, EHR, and the clinical data exchange. So there we focus more on privacy, security standards, HIPAA, and standards like 27001, and that's how we can look at the parallels between IHE and ISO, where that everyone is trying to shape the adoption of AI and ensure we're doing it in a proper way. So IHE is leading the charge in defining how AI fits into radiology workflow, while ISO is shaping global AI governance, and how is that going to be implemented on a very high level.
So I'm curious. First, I'm going to ask a question about IHE, and it comes about adoption and participation from the vendor community. Often, vendors don't just willingly go down the path of adopting standards unless they're being see a market for it, unless the customers are asking for specific interoperability use cases, and then they start participating or seeing the value. A lot of new vendors have entered this space. So we're not necessarily dealing with the old heads of like GE, Siemens, AGFA, etc. Like we're seeing a lot of new vendors entering the space, a lot of young vendors. Are you seeing that level of participation from a new set of vendors in IHE, or is that a challenge getting them on board to appreciate that that there is this thing called IHE that has meaningful value for interoperability?
Yeah, this is a really a good question, and I had dealt with that directly. We looked at a lot of new AI vendors, and because all of them are trying to solve in each problem that they think that it's useful, but they don't have the experience that big players like GE, Siemens, Agfa, and Philips have, and the understanding of IHE and DICOM and HL7, and the participation, of course, in those, standard development organization. The new AI vendor focus more on getting FDA clearance first. So that is their main focus. They, as you mentioned, exactly, if the customer is asking for a specific, way of representing the data, then they are willing to invest into that because it's not easy. DICOM standard textbook by David, as you know, is like that much. But and one of the CEOs actually told me that if the customer insists on us having the representation according to the air profile, then I will invest into having one of the engineers learn about that and actually but other than that, I am busy with the FDA improving the performance and the sales and marketing aspects. So IHE comes as like an afterthought.
They almost have a marketing challenge where the vendor's not going to do it unless the customer asks. Many times, your general customer is not necessarily acquainted with IHE enough to even start asking these right questions. I think there's an education challenge around making sure the customers know what they're asking for, can ask for the right IHE profiles, and identifying like the actors and so on, and that will drive the change hopefully. But yeah, I think there's a bit of a marketing or an educational gap sometimes between the operational folks and the standards world.
Yeah. And that's why I encourage many clinicians or people who are in these hospital systems to give awareness to the clinicians about the importance of the interoperability standards like IHE and DICOM, and so that's the training. I see also a nice lecture at ECR by Sergey and from 3R in Europe, and that was really a good example of spreading awareness. And I told him, do you really see the same kind of pushback from the vendors when you asked about that? And he confirmed that he does try to encourage them to adhere to the standards, but at the end of the day, they are service provider and they need to help get their work done. And I believe that we can do some like incentives to the AI vendors by encouraging them to adhere to the standards, attend the IHE connectathons and testing. I attended those, and there is not a lot of participation from vendors, and they often skip that step. But if we have the regulatory bodies or payers ensure like IHE compliance in the RFPs and tenders and in the FDA CE approval process, that will force them to take that more seriously. And of course, there are the open source tools and standardized APIs like MONAI, which is the medical open network for AI, where I participate in the MONAI deploy working group. And the goal of that initiative is basically to democratize the AI by providing the tools for new vendors, for anyone who would like to start using tool. And that's why we have a very lenient license scheme for that, and people can build on that and utilize it in making products. So we try to build in the adherence to the IHE profile, and it is on us to participate in IHE Connectathon, like which we do actually. We did that, and now the people, vendors, or the enthusiast can take a solution that is already adherent to compliant with the IHE profile recommendation.
Earlier on in your answer, you had mentioned reference to ECR. So recently you had submitted a couple abstracts to the ECR. There was one that was on AI assisted annotation and federated learning for RCC image segmentation. And I thought for those that are dialing in or accessing this right now, maybe you could just provide a bit of set the table for what is federated learning, and then how is that helping improve tumor segmentation according to what you were presenting in the abstract.
Yeah. So basically, federated learning is the type of learning where you don't have to bring the data to a centralized place and apply the training on that because of many hurdles. Are privacy concerns, like people who don't want to share patients' data, especially if the collaboration is international between different countries, and there are strict rules about data not leaving certain countries. And instead of the data moving, which can be also expensive, now the federated learning is one type of a larger category called collaborative learning, where instead of sharing the data, we just connect to a central hub. We call it the server, federated learning server, and that server kind of administer the sharing of the model parameter updates among the different clients. So the data stays where it's at, and they get the model. The initial model is distributed among all participants, and then they will train on their own data, and then they will share their suggestions of what is the model parameter update should be. And then they pass that to the server, which sends it in turn to another client, and the other client try to do that on its own data, and so on until the model is performing as desired. So what that does is ensures that you have generalizability, and you're maintaining the privacy, and you're adhering to all of the requirements, compliance with HIPAA, GDPR, and local IRBs in hospitals. And we noticed that it also improves the performance of the model rather than train on a centralized data set. And in this case, we looked at renal cell carcinoma, and we had a project that is mainly run by the Society for Imaging Informatics in Medicine, SIM, Machine Learning Research and Tools Committee, which I chair. And we have participants from Vanderbilt University, is the co-chair, and the University of Wisconsin-Madison, the project lead there, John Garrett. We also have, participants from VA, University of California, San Diego, and also Stanford participated with us as well. And that is the topic of the first basically abstract that was presented at ECR.
So I'm gonna ask two more questions. I think I could go on and on. I could keep asking you another questions to try to keep these a little constrained on the time. But I think I would like to have you back. I think we could just keep going for a long time. I'm gonna circle back to when you were talking about ISO, and you had mentioned some of the risk mitigation, and we're gonna go back to that bias. And so this is a big challenge often, where I often give the example in Toronto here, we live in a very multicultural society. So you have people from all over the world that have arrived in the city. And so a model that is trained on, whatever Kansas City population is not going to apply to that population. And you could apply that to any two different cities. And that fundamentally is a data challenge. And it's a matter of what are you training the models on? But I'm wondering if there's more to it that you can explain beyond that, and how we can look at mitigating bias in those types of scenarios.
Yeah. This is a very important question, especially now, as we have seen that the issue of ethical AI and responsible AI is really very important, and it's been taken seriously by the providers and users and regulatory. The most obvious challenge is, as you mentioned, the data. If you are to train the model on limited region-specific data sets, then you have underrepresentation of the other population. So the models tend to do good on what they are trained on. If they see some changes, and the changes can come from genetics, imaging protocols, disease prevalence, that will affect the model. So I told you, to fix that, we can come up with either federated learning or multi-center data collaboration. And so we have diverse data set. But recently there is a lot of surge of synthetic data. We have seen that GTC that's taking
Sure.
place, GPU, the technical conference by NVIDIA, where the simulation power now matches almost exactly the physical performance. The simulators now can provide us with a lot of reasonable data that is AI augmented or generated, and that could help actually balance the underrepresented groups. And there is also the issue of reevaluation, because the model drift is a common problem where somehow with time the data changes in characteristic from the initial data that so the data, as I said, is one of the main aspects, but still it is not, because you have the algorithmic biases. Like, this is the hidden problem. Just like what we explained before, the model, you can design the model with different architectures. So the way that you choose the model, some of them are more susceptible to data change than others, which there is like fine tuning. If it's overcomplicated, then it will not generalize better. And I told you about the feature selection. So sometimes what you feed the algorithm can also help with learning patterns that not necessarily indicative of the real problem. There was a nice example at the NIH Primate, workshop that took place last week, where the moderator told about the COVID example. Like, most of the data that were used for training initial models were taken from adults, because that was the COVID started with adults. The model then, it wasn't actually discriminating between people who have COVID versus not. It was actually classifying whether this is a pediatric patient or adult patient. And that ends up in complete ignorance of the population, and bad performance on the pediatrics. So this requires adaptive AI systems and diverse AI development to team. Because the problem with AI development and AI vendors basically is they are good in machine learning and using of deep learning in encoding, but they don't understand the healthcare system, which is very complicated, and there are so many aspects to it. So that's where they introduce these algorithmic biases because of ignorance. So that's why consultants play a very good, important role in explaining that and giving some insider insights about the problem and the design. You have also the regulatory bodies, as I said. And actually, I've written a blog about bias at my website at Media Consult, and it tackles the different types of biases as well as the role of regulatory bodies and mitigating those. So, for example, I told you about the AI risk management standards by ISO IEC JTC Subcommittee 42, but we have also very nice work done by NIST, the National Institute for Standards and Technology, where they had laid out a very detailed report of how to tackle these harmful biases, and that was referred to for in their other publications about the AI risk management guidelines. So regulatory plays a real role, and we have to ensure accountability. Because NEST, for example, HE and ISO, they give recommendations, but they don't enforce it.
They're not police.
Yes. But what I found out is like the regulatory, the acts done by states like the state of California and New York, they are more stricter, and they enforce to that because they want to protect their population.
I said I was going to ask two more questions. I might ask another one, fit one more in. You mentioned the simulated data and simulating in the absence of having robust data sets. How far along are we into that journey? Do people feel confident in that approach?
Basically, that has been there for a very long time, but it did not reach the maturity and reliability that we have right now. So, which is generative adversarial network, is one example of that, and it's been used to create realistic images for AI training. You have also CT and MRI. They can generate some synthetic data, generate anatomically accurate, actually, synthetic data. But things have started to pick up speed. I know that there is some trust issue, between users, clinicians. Synthetic data is truly representative of real world cases, and they also worry about the bias again. If the original data is biased, then generating more synthetic data will just amplify the bias.
Like a bad photocopy.
Yes. So I think things needs to be regulated. I said earlier, and I think that we can use a hybrid training where we have to use the real data in addition to the synthetic data in a trustworthy format. And I like the GTC keynote speech by Jensen yesterday, where he said that we know about LLMs and we know about the power of reinforcement learning with verifiable output. And he said, like, what is verifiable? What's best verifiable aspect better than physics? So we need to develop a physics engine. It's like a robot that moves and acts and be very aware of the circumstances, and it doesn't fall, and it's not clumsy in the movement. And basically they introduced their new product, which is a Newton, which is like a pet robot that interacts in a very nice way with people, and that was done in cooperation with Google DeepMind and Disney research.
Wow. Oh, we'll close it off with one last question here, and I'd like to hear, what are you personally most excited about? There's a lot things going on. If you were to look at where we're going over the next couple of years, where do you find the most excitement when it comes to AI and ML in the imaging space?
Yeah. Actually, what I am really interested in, I get, of course, we see how good now the ambient systems are, and there are a lot of solutions in the market by, Ambience and Abridge and RadAI, Hopper and Microsoft Nuance. And this is really good because it moves the workflow and enhances productivity. But I believe the power of real-time decision support, real-time, because that's where, for example, pneumothorax is like algorithm that was developed by GE. It helps to find the patient that has pneumothorax on the spot, on device, before actually the patient goes, back home. So this power is good. We see a lot of robotics now that use AI-assisted intervention guidance. My son is in the urology department at Cleveland Clinic, and they are using Da Vinci machine there, and it's really producing a lot of favorable results. And the other aspect that I like is the multimodality, because if you look at the real world around us, it's multimodal. We read text, we listen to music, we see images. And so having the silos of information like EHR data, pathology slides, DICOM images, and trying to come up with a team of experts utilizing these data is good, but it's nothing like to truly combine these multi-imaging data, genomics, radiomics, pathomics, all of these in a multimodal system that will give a holistic patient view, and it will integrate the lab results, the history, and enables precision diagnosis. I think that, to your point of not focusing on only imaging, I also like to focus on the interoperability, and I believe that if we really have real interoperable where the data flows seamlessly between the devices, and we don't have the pushback from EHR vendors and the monopoly played by certain companies, and the lack of openness and sharing the data, then that will make the development of AI models much faster and more reliable, which ensures a smarter healthcare system.
Terrific. This has been a great conversation, Khaled. I really appreciate you taking the time. And I will include any relevant links, the blog definitely, but anything else you'd like me to include, we'll make sure it's in there. And thank you very much.
The Dream Machine. DICOM, HL7, IHE and Snap. We're building the future, never looking back.